Hello, you want to learn UEL Subroutine in Abaqus easily and quickly. UEL is a subroutine to define a new element in Abaqus. Consider you have a one-dimensional element with points A and B. For example, temperature in this element is interpolating between the temperature of point A and temperature of point B. So a interpolation function computes and defines the temperature in any points in this element. If you want to have more precise solution, you need to add point C and a new interpolation function. Interpolation function can be linear or cubic. You need to define your function in UEL subroutine. For 2 and 3 dimensional problems, it's same. We need to define a new element with a new interpolation function. To well understand these things, stay with us. UEL variables. UEL has some variables. Some of them are inputs. We need to get those inputs, processed on them, and export them as outputs to the Abaqus. In other words, Abaqus computes some variables, which is the displacement of the points, the derivative of displacement of the points, the velocity of the points, coordinates and position of the points, and these variables. We need to get these variables and define interpolation matrix, interpolation function, and the elements, force matrix, variables, and return these new variables, return back to the Abaqus. Again, Abaqus gets these variables and compute the U, du, v curves. This is how Abaqus and UEL interact with each other, which is necessary to well understand to write well-working UEL subroutines. As an example, I explain one of the most important variables here, which is the output of UEL, RHS, right-hand side matrix. Strain is a function of displacement. Here we add curvature for that. K is curvature. Strain and curvature is a function of UE, which is displacement, by a matrix we call B matrix. And when we compute strain and curvature, then we can compute the force and momentum by this strain and curvature with D. D here is a stiffness matrix, or in one-dimensional problems, F equals to D epsilon. D is E Young modulus, elastic stiffness matrix. So this is the construct equation. Here we solve, by this method, we solve our problem. So RHS is F, which is, by combining these two equations, which is integration in the length of the element or area or volume of the element of BFM dl. So you understand what is the RHS you need to update in your problem. It needs more explanations for A matrix and all the variables. We say you can learn UEL easily and quickly, but is it really possible to learn UEL simply in a week? How? UEL has many variables, many details, but do you really need to understand all details to solve your problem? Of course not. Only necessary aspects are enough. By focusing on your problem, your element, and your formulation, you can save your time and energy. we have done this for you by a UEL Subroutine training package for you. In this package, the formulation is explained in a video by details. The UEL variables are explained, something I explained for RHS, for all variables in detail. The whole UEL subroutine is explained line by line in another video. A UEL needs to be solved in Abaqus input file, so Abaqus input file is explained step by step in another video. Result extraction is explained also, and all Abaqus UEL files are included also in this package. This package includes 3 examples. Example number 1 with a simple UEL and most necessary details are explained like RHS and A metrics. Example number 2, it is a medium UEL with more details. And example number 3 is complex UEL in which all details are explained. It is a systematic way to learn complex UEL subroutine. You can download this package by the link in the description or directly go to freelancers.uk. You want more? You don't have time to learn these things and you want your UEL to be written sooner? Okay, we can write your UEL and test it by published results and teach it to you by online meetings and videos. Again, you can order your project by the link in the description or directly go to the freelancers.uk. Thank you for your attention. Hello, you want to learn UMesh motion subroutine in Abaqus easily and quickly. Indeed, UMesh motion is a subroutine to define mesh displacement or mesh velocity in Abaqus. This subroutine is being used mainly in VR problems to prevent mesh problems in adaptive meshing. Stay with us. UMesh motion variables. UMesh motion has some variables. Some of them are inputs. We need to get those inputs, processed on them, and export those inputs as an output into the Abaqus. In other words, Abaqus computes nodes positions, time, variables. We need to get these variables and processed in the UMesh motion and compute the displacement or velocity of the nodes in X, Y, and Z direction and return these variables into the Abaqus. Abaqus uses again these variables to recompute the nodes positions and all the necessary variables. This is how Abaqus and UMesh motion interact with each other, which is necessary to well understand to write a well-working UMesh motion subroutine. Here I explain one of the variables, U local. Consider you have a point x1, y1, z1. This point is going to be transferred to point 2. So U local 1 is the displacement or velocity in x direction, U local 2 in 2 direction, y direction, and U local 3 in 3 direction or z direction. And these variables needs to be well explained to understand the UMesh motion, which is one of the complex subroutines in Abaqus. We say you can learn easy and fast, but is it really possible to learn UMesh motion simply in a week? How? UMesh motion has many details, but do you really need to know all details and variables to write your problem or to write your UMesh motion subroutine? Of course not. Only necessary aspects are enough. By focusing on your problems and your variables, you can save your energy and your time. To this end, we have prepared a UMesh motion training package for you. In this package, the U-mesh motion formulation is explained in the video. U-mesh motion variables are explained in detail, and U-mesh motion subroutine is explained line by line in the videos. Any U-mesh motion subroutine needs to be solved by Abaqus solver. So Abaqus model is explained step by step in separated video, and at the end result extraction is explained in another video, and all Abaqus and U-mesh motion files are included in this package. By this package you can learn U-mesh motion systematically and easily. This package includes 3 examples. Example number 1, which is a simple U-mesh motion and most necessary details are explained. Example number 2, which is a medium U-mesh motion and more details are explained. And in example number 3, which is a complex U-mesh motion, all details are explained in videos. You can download this package by the link in the description or directly go to feassist.uk. You want more, you don't have enough time, and you want your U-mesh motion subroutine to be written sooner. Okay, we can write your U-mesh motion subroutine, test it with published results, and teach it to you by online meetings and training videos. Again, you can order your project by the link in the description or directly go to feassist.uk. Thank you for your attention. Hello, you want to learn VD-Flux subroutine in Abaqus easily and quickly. Actually, VD-Flux is a subroutine to have a movable heat source on your plate or on your sample, which is being used in some processes like welding or additive manufacturing. This subroutine VD-Flux is being solved by a temperature displacement explicit solver in Abaqus. D-Flux is being solved in a standard VD-Flux by explicit solver actually. To understand how does it work, actually stay with us. VD-Flux formulation. Before that, going to the details of the formulation, you need to understand the meaning of flux. What is the energy flux or heat flux or mass flux? Flux in heat, flux means the amount of heat transferring from a unit of area in unit of time. So this is the definition of flux or heat. Actually, we define the flux in heat treatment or heat transfer problems as a Q equals to minus K dt dx. So, and for mass diffusion is dc dx, which means dc actually is the concentration and d is diffusion coefficient. VD-Flux variables. VD-Flux has some inputs coming from Abaqus. We need to process on them and export the value here actually as a output to Abaqus. In other words, Abaqus computes some variables like temperature, like velocity, like actually time, and this time, temperature, velocity variables is transferred from the Abaqus to VD-Flux. In VD-Flux, we need to get these variables and recompute the value, which is the flux. So the value or flux is transferred to the Abaqus. Abaqus will use this value to recompute the time, temperature, velocity, and other variables. This is how Abaqus and VD-Flux interact with each other, which is necessary to understand if you want to write a good VD-Flux. For example, value here as I said, is the amount of the flux that you need to define in your subroutine based on your formulation. We say you can learn VD flux easy and fast, but is it really possible to learn VD flux simply in a week for the beginners? The answer comes from a question. Do you really need to know all the details? VD flux has many details, many formulations, and very complex form could be. But do you really need to know all of them? Of course not. By focusing on your formulation and your problem, you can save your time and you can save your energy. We have done that for you. We have prepared a training package for you, which is VD Flux Subroutine in Abaqus. In this package, the formulation, the heat treatment, the mass transfer, the mass diffusion formulations are explained. The VD Flux Subroutine variables actually are explained, all of them are explained. The whole VD Flux subroutine is explained line by line in the videos. Any VD flux needs to be solved in Abaqus solver, so Abaqus model is explained step by step, and at the end result extraction will be teach actually to you. All Abaqus files and subroutine files are included also in this package. This package includes 3 examples. Example number 1, which is a simple VD flux subroutine and in which most necessary details are explained for the beginner. Example number 2, which is a medium VD flux, more details are explained. And in example number 3, which is a complex VD flux, all details are explained to be expert in writing VD flux. You can simply download this package from the link in the description or directly going to feassist.uk. You need more? You don't have time? You want your VD flux to be written sooner? Okay, we can write your subroutine for you, test it, verify it with published results, and teach it to you in online meetings and videos. So again, you can order your project by the link in the description. Thank you very much. Hello, you want to learn VU Expand subroutine in Abaqus easily and quickly. VU Expand is a subroutine to define thermal expansion in Abaqus. Stay with us. VU Expand formulation. The materials change size when heating. In other words, if you increase the temperature of a sample, the length of the sample in all directions will increase. How much? It depends on thermal expansion coefficient. Why? If you have a look in atomic view, we will find that the frequency distance of atoms increases in heating, and this is the reason of thermal expansion. VU Expand variables, VU Expand inputs and outputs. VU Expand has some inputs. We need to get those inputs, process them, and export new variables as an outputs into the Abaqus. In other words, Abaqus computes the temperature, time, state variables, transfer these variables as an inputs into the VU Expand subroutine. In VU Expand subroutine, we need to process on these variables and compute new variables like strain increment, the thermal strain increment, state variables, and all the outputs, and return back these outputs in the Abaqus. Again, Abaqus uses these values to compute the new values for temperature, for time, state variables. This is how Abaqus and VU Expand interact with each other, which is necessary to well understand to write good VU Expand subroutines. For example, I explain one of the variables here, strain thermal increment, delta L per L0 is equals to thermal expansion multiplied by delta T. So this thermal strain needs to be written and defined in VUExpand subroutine. We say that you can learn easy and fast, but is it really possible to learn VUExpand subroutine simply in a week? How? VUExpand has many details, many variables, but do you really need to know all details to write your VUExpand subroutine? Of course not. Only necessary aspects are enough. By focusing on your formulation, you can save your energy and your time. To this end, we have prepared for you a VUExpand training subroutine package in Abaqus, which includes a video of explaining formulations, video explaining the VUExpand subroutine variables, and the video explaining the VUExpand subroutine, the whole subroutine, line by line. Any VUExpand subroutine needs to be solved by Abaqus solver, so the Abaqus model is explained step by step. Result extraction is explained in the videos, and all Abaqus and VUExpand files are included in this package. This package includes 3 examples: a simple VUExpand subroutine in which most necessary details are explained, example number 2, which is a medium VUExpand subroutine with more details, and example number 3, which is a complex VUExpand with all details. You can download now this package by the link in the description or directly go to feassist.uk. You need more? You don't have time. You want your VUExpand to be written sooner? Okay, you can write your VUExpand, test it with published results, and teach it to you with training videos and online meetings. You can order your project by the link in the description or again go directly to feassist.uk. Thank you for your attention. Hello. You want to learn VUMath subroutine in Abaqus easily and quickly. UMath is a subroutine to define a new mechanical behavior for materials. Stay with us. The first question, which is very important, is that why VUMath? Why we need VUMath to solve our problem? Consider you have a sample and you want to apply load for that in a dynamic way and predict by modeling and simulation the mechanical response, the stress-strain behavior, or the load displacement curve. The first strategy is that you have some of the points of your stress-strain or load displacement curve from the lab or published experimental results. Then you can easily go to the Abaqus property, define a new material, go to the plastic behavior and enter those points like this. Abaqus interpolates between these points and predicts the behavior of the material in all points. This is the simplest way, but it is not precise because of interpolation. If you want to solve your problem more precise, then you need to have the constitutive behavior or constitutive equation of your material. Your material mechanically obeys some rules. If you have equation and the equation is included in the Abaqus, Then you can go to the Abaqus again to property, materials, mechanical, and instead of entering the points, define the behavior. For example, here it is a Johnson Cook. You can enter the parameters and constants of your equations. Abaqus will solve your problem in all points based on this equation. This is more precise because you have equation. But if you have a new equation for a new material, new consumer equation, and the equation is not included in the Abaqus to enter the parameters and constants, then you will need a place to write your equations and force the Abaqus to solve the problem based on your equations. This place is VUMAT Subroutine. The important thing about the VUMAT Subroutine learning is UMAT actually inputs and outputs. VUMAT inputs and outputs. VUMAT has some variables. Some of them are inputs from the Abaqus. In VUMAT, we process on the inputs and export the processed inputs as an outputs. Actually, these variables are computed in the Abaqus. The old values or the initial values transferred to the VUMAT. Into the VUMAT, we need to write a new equation or some new equations to redefine these values, and the new values of the variables return back to the Abaqus. This is how Abaqus and VUMAT interact with each other, which is necessary to understand to write a good working VUMAT. Here we explain one of the most important variables of VUMAT subroutine, which is stress, and here stress new. Consider you have a stress and a strain at this point, and you want to predict and compute the stress at the next point. What you can do? In a dynamic way, the strategy is that the new value is the old value plus the derivative function, which is the function of the slope of the diagram and the incremental amount of the strain, as you can see here. For example, in elasticity and elastic problems, the slope is elastic modulus or elasticity stiffness matrix. Well understanding of all these variables actually is necessary to write a good VUMAT. We say you can learn VUMAT easy and fast, but is it really possible to learn VUMAT simply in a week? If yes, how? VUMAT has many details, variables, and interactions, but do you really need to know all details to solve your problem? Of course not. Only necessary aspects are enough. If you want to learn all aspects and interactions and equations and the functions of the VUMAT, maybe you will need more than 5 years, and you don't have this time. So you can save your energy and you can save your time by understanding only necessary aspects to solve your problem. But how? We have prepared for you a VUMAT training package in which you can solve your problem by understanding only necessary aspects. In this package, there are some videos explaining the formulation, the constitutive equation, the relation between stress, strain, temperature, and strain rate. The VUMAT variables are explained in the videos. The whole VUMAT is explained line by line by details in the videos. Any VUMAT needs to be solved by Abaqus solver, then Abaqus model is explained step by step. The result extraction and comparing with the experiments is explained in other videos, and all Abaqus and VUMAT files are also included in this package. This package includes 3 examples. Example number 1, which is a simple VUMAT and most necessary details are explained for the beginners. Example number 2, which is a medium VUMAT and more details are explained for actually to be more expert. And example number 3, which is a complex VUMAT and almost all details are explained for advanced users. To download this package, you can click on the download link in description or go to our website feassist.uk. You need more? You don't have time? And you want your VUMAT to be written sooner? Okay, we can write your VUMAT, test it, verify and validate it with experimental results and teach it to you in videos and online meetings. You can order your project also by the link in description or referring to our website feassist.uk. Thank you for your attention. Hello. You want to learn UMAT subroutine in Abaqus easily and quickly. UMAT is a subroutine to define a new mechanical behavior for materials. Stay with us. The first question, which is very important, is that why UMAT? Why we need UMAT subroutine? Consider you have a sample and you want to apply load and by modeling and simulating predict the mechanical response of this sample, predicting the stress strain curve. The first strategy is that you have some of the points of your stress strain behavior from lab or from published experiments. You can easily go to the Abaqus, to the property, define a new mechanical behavior, plastic behavior, and enter those points like this. This is the simplest way of solving the problem, but it is not precise because Abaqus interpolates between these points and solves the problem in all points. If you want to solve your problem more precisely, then you need to have a constitutive equation, a constitutive behavior for your material. An equation in which the stress is a function of strain, temperature, and strain rate. In this example, we have equation, we have a material obeys this equation, which is Johnson-Cook equation. Again, if you have the constitutive equation, which is well known and included in the Abaqus, you can go to the Abaqus, again go to the property, define a material, and instead of entering the points, you can define the behavior and enter the parameters and constants of your model. Here it is Johnson-Cook model. It is more precise solution because you have an equation for all your points. But consider you have a material or a new material or a new constitutive equation. The equation between stress and the components is very new, which is not included in the Abaqus, and you don't have points. So what you can do? Then you need a place to write this equation or your equations and define the Abaqus that obey this behavior to solve my problem. This is the reason we need UMAT, because our equation is new. The next important thing about any subroutine, especially UMAT, is UMAT inputs and outputs. UMAT is a machine, accepts some inputs, process on inputs, and export the inputs as an outputs. UMAT has some variables: stress, strain, DDS, DDE, and some of the variables you can see here. Actually, all these variables are being computed in the Abaqus, transferred to the UMAT. In the UMAT, we need to write some equations based on our conserved behavior to recompute these variables, all the variables, and return back all these variables to the Abaqus. This is how Abaqus and UMAT interact with each other, which is necessary to write a well-working UMAT. Here, for an example, we explain one of the most important variables of UMAT, which is DDS, DDE. Consider you have a stress and a strain at this point, and you want to compute or predict the stress at the next point. How you can do that? The first thing comes into the mind is that you have the slope of the diagram. If you have the slope of the delta stress with respect to delta strain, then you can linearly solve this problem and predict the stress at each point. So if you have a stress as a function of a strain, then by making a derivative, you can define the DDS, DDE for your formulation. So we call this slope of the diagram DDS, DDE. This is the nature of this variable. For all variables based on your equation, you need to well understand the nature and the source of the variables. For example, in elastic regime and for elastic problems, the elastic stiffness matrix is DDS, DDE matrix. We say that you can learn UMAT easy and fast, but is it really possible to learn UMAT in a week? If yes, how? UMAT has many details, many variables, but do you really need to know all details to solve your problem? Of course not. Only necessary aspects are enough to solve your problem. UMAT has many details. If you want to learn all details, maybe you will need more than 5 years to be an expert in UMAT writing. But in your problem, no. Maybe in your equations, only 3 of them are enough for you. So you can save your time and save your energy. To this end, we have prepared a UMAT training package for you. This package includes some videos. A video explaining the formulation, all the conserved equations. The next videos explain UMAT variables, something like I explained the DDS, DDE. Another video explains whole UMAT line by line, how the formulation converted to UMAT codes. Any UMAT needs to be solved in Abaqus software. So the Abaqus models actually are explained step by step in another videos. At the end, the result extraction and comparing with the experiments is explained. All Abaqus and UMAT files are also included in this package by downloading. This package includes 3 examples. Example number 1, which is a simple UMAT, only most necessary details are explained for beginners. Example number 2, which is medium UMAT, more details are explained to be more expert. And example number 3, which is a complex UMAT, all details are explained for advanced users. You can simply download this package and use it to learn UMAT easily and quickly by the link in the description or from the website, our website freelancers.uk. You need more, you don't have time, you don't want to learn every aspect, and you want your UMAT to be written sooner. Okay, we can write your UMAT, test it, verify it with published results, and teach it to you with videos and meetings. So you can order your project also by the link in the description or the website freelancers.uk. Thank you for your attention. Hello, you want to learn UEXpand subroutine in Abaqus easily and quickly. UEXpand is a subroutine to define thermal expansion in Abaqus. Stay with us. UEXpand formulation. Materials change size when heating. If you increase the temperature of a sample, the length of the sample will increase. How much? It depends on coefficient of thermal expansion. Why? If you look at the atomic view, you will find that the frequency distance of atoms increases by heating. This is the reason of thermal expansion. UEXpand variables. UEXpand inputs and outputs. UEXpand subroutine have some inputs and we need to process them and export as an output to the Abaqus. In other words, Abaqus computes temperature, time, state variables. We need to use these variables in UEXpand subroutine and define the expansion coefficient, the derivative of the expansion coefficient with respect to time, to temperature, state variables, and return these variables to the Abaqus. Again, Abaqus use these variables to recompute temperature, time, state variables. This is how UEXpand and Abaqus interact with each other, which is necessary to well understand to write a good UEXpand subroutine. For example, one of these variables, expand. Actually, delta L per L0, which is the normalized length increase, is equals to thermal expansion coefficient multiplied by delta T, which is temperature increase. This alpha should be defined in this subroutine. We say that you can learn UEXpand subroutine actually easy and fast, but is it really possible to learn UEXpand simply in a week? How? If you look at the subroutine and variables, you will find that UEXpand has many details, many variables. But do you really need to know all details to write your UEXpand subroutine? Of course not. Only necessary aspects are enough to write your UEXpand subroutine. To do that, we have prepared for you a package, a UEXpand subroutine training package. In this package, formulation of UXpan are explained in details in videos. The variables are explained in videos, all UXpan variables. UXpan, all the subroutine is explained line by line in the videos for the beginners. Every UXpan subroutine needs to be solved by Abaqus solver. So Abaqus model is explained also step by step in the videos. At the end, result extraction are explained actually in the separate videos. All Abaqus and UXpan files are also included in this package. This package includes 3 examples. A simple UXpan example in which only most necessary details are explained. A medium UXpan subroutine in which more details are explained. And a complex UXpan subroutine, all details are explained for someone who wants to be expert in UXpan writing. You can download this UXpan subroutine training package in the link in the description, or directly go to feassist.uk and download it. You need more? You don't have time. You want your UXpan subroutine to be written sooner? Okay, we can write your UXpan subroutine and test it with published results and teach it to you by online meetings and training videos. Again, you can order your project by the link in description or directly go to the feassist.uk. Thank you for your attention. Hello. Here we want to explain impact in Abaqus. You can learn it to model easily and quickly by this video. One of the samples you can see in this video. And the next sample, high velocity and low velocity impacts. To understand how to do that, stay with us. We can say you can learn it easy and fast, but do you really need to understand all details to solve your problem? Of course not. By focusing on your problem, you can save your energy and your time and learn it much faster and much easier. To this end, we have prepared the Impact in Abaqus training package for you. In this package, the formulation of impact is explained, impact variables are explained, Abaqus model explained step by step, result extraction from impact, and all Abaqus files are also included in this package. You can simply download this package by the link in description or directly go to feassist.uk. You want more? You don't have time and you want your impact problem to be solved sooner? Okay, we can write it, we can do it for you, test it and teach it to you by online meeting and videos. Again, you can order your project by the link in description or directly go to feassist.uk. Thank you for your attention. Hello. Here we want to explain frictionless stir welding or FSW with deflux subroutine in Abaqus. You can learn it easily and quickly by this video. To understand how to do that, stay with us. We say you can learn it easy and fast, but is it really possible to learn deflux subroutine and FSW simply in a week? Deflux has many variables, but do you really need to understand all details to solve your problem? Of course not. By focusing on your formulation and your variables, you can save your energy and your time. To this end, we have prepared the FSW training package for you. In this package, the formulation of FSW is explained in the video. Difflux variables are explained in the video. In the next video, whole difflux subroutine is explained line by line for the beginners. Any difflux subroutine needs to be solved by Abaqus solver, so Abaqus model is also explained step by step in another video. And at the end, result extraction is explained actually in the next video. And all Abaqus and difflux files are also included in this package. This package includes 3 examples. Example number 1, which is a simple difflux and most necessary aspects are explained. Example number 2, which is a medium difflux, more details explained for the experts. And example number 3, which is FSW, and the difflux for FSW and FSW with all details are explained. Download link in description. You can download this package with the link in description or directly go to faassist.uk. You want more, you don't have enough time and you want your problem to be solved sooner, okay, we can write your subroutine, test it with published results and teach it to you by online meetings and videos. So again, you can order your project by the link in description or directly go to FAE Assist. Thank you for your attention. Hello, you want to learn difflux subroutine in Abaqus easily and quickly. Indeed, difflux is a subroutine to define heat flux in heat transfer problems and mass flux in mass diffusion problems. In other words, if you want to have movable heat source like laser or movable object in your problems like carbon atom diffusion, you need to define difflux problem. Stay with us. Difflux formulation. Before going to details of formulation, you need to understand flux. What is flux? In heat transfer problems, flux is the amount of heat, the amount of energy transferring from a unit of area in unit of time, which is a function of derivative of temperature with respect to x in one-dimensional problems. Or for mass diffusion problems, it is a function of concentration with respect to x. And in mass diffusion problems, flux is the amount of objects, the amount of atoms, the amount of molecules, the amount of moving objects transferring from unit of area in unit of time. Difflux variables. Difflux has some inputs. We need those inputs processed on the inputs and export those processed inputs as an output into the Abaqus. In other words, Abaqus computes time, temperature, pressure, other variables. We need to get these variables and write our fluxes, and actually flux 1 and flux 2, and return back to the Abaqus. Again, Abaqus gets flux 1 and flux 2 and computes the new variables time, temperature, pressure and other variables. So this is how Abaqus and difflux interact with each other. We need to well understand this interaction to write good difflux subroutines. For example, what is flux 1? Flux 1 is actually the derivative of temperature with respect to x, and flux 2 is the derivative of flux with respect to temperature. It is written based on your formulation. We say you can learn easy and fast actually the difflux subroutine. But is it really possible to learn difflux subroutine simply in a week? Difflux has some variables, many details, but do you really need to understand all details to write your difflux problem, your difflux actually subroutine? Of course not. Only necessary aspects are enough. by actually focusing on your problem, you can save your time and your energy. To this end, we have prepared a Deflux training package. In this package, formulation actually is explained in details in video. It is another videos actually explaining Deflux variables. The whole Deflux subroutines are explained line by line in the videos. Any Deflux needs to be solved in Abaqus, so Abaqus models are explained step by step. And at the end, result extraction is explained in the videos. All Abaqus Deflux files are included in this package for downloads. Actually, this package includes 3 examples. Example number 1, which is a simple Deflux and most necessary details are explained for beginners. Example number 2, which is a medium Deflux, more details are explained. And example number 3, which is a complex Deflux and all details are explained. You can download this package from the link in the description or directly going to feassist.uk. You need more. You don't have time actually, and you want your Deflux to be written sooner. Okay, we can write your Deflux subroutine, test it, verify it by published results, and teach it to you in videos and online meetings. Again, you can order your project by the link in description or directly going to feassist.uk. Thank you for your attention. Hello, you want to learn creep subroutine in Abaqus easily and quickly. Creep is a subroutine to define time-dependent plasticity or viscoplastic behavior of materials. Stay with us. Creep formulation. In creep formulation, creep strain rate is a function of stress, strain, time, temperature, or other variables. This function has some forms. For example, time-dependent creep, in which strain rate is a function of deviatoric stress and time. By entering the parameters A, N, and M, you can predict the behavior by this equation. This equation is very simple, but it is not precise. Other form of creep function is power law function, in which the creep strain rate is a function of creep strain actually and deviatoric stress. Some of the parameters are here. By entering these parameters into the Abaqus, you can again predict the behavior. Other form of the creep function is sinus hyperbolic function, in which creep is a function of deviatoric stress and actually energy and temperature. You can go to Abaqus, go to property, mechanical section, plasticity, and there you can see creep and swelling option, and in that section you can enter all these parameters and predict the behavior. But mostly you cannot predict the experimental behaviors, and you cannot fit the curves, experimental curves, by these equations. So you need a place to actually write your creep formulation there and force Abaqus software to solve the creep problem based on your new equation, which is not one of these equations. This place is creep subroutine. Creep variables. Creep subroutine has some variables, some inputs and some outputs. Actually, some of these variables are inputs from Abaqus And in creep subroutine, we do some calculations on them, we process them, and we return the new values to the Abaqus. Indeed, Abaqus computes the creep variables, actually transfer the variables, which is time, temperature, deviatory stress, into the creep. In creep, we need to define the creep strains or swelling strains, the state variables, and return them back to the Abaqus. Abaqus actually again will use the creep strain to compute the temperature, the stress, and these variables, and this loop will continue to solve our problem. This is how Abaqus and creep interact with each other, which is very important and necessary to write a good creep subroutine. We say that you can learn creep subroutine easily and fast, but is it really possible to learn creep subroutine simply in a week? How? Creep have some variables and details, but do you really need to know all details to solve your problem? Of course not. Only necessary aspects are enough. If you want to learn all creep formulations, you don't need them, and you can actually save your time and energy and learn those aspects that you need in your problem. So, based on this, we have prepared a creep training package for you, which is included many things actually in this package that you can easily learn creep subroutine. In this package, all formulations are explained in details in videos. Creep variables, creep inputs, creep outputs are explained, all of them actually. The creep subroutine is explained line by line in the videos. The details are explained. Any creep subroutine needs to be solved by Abaqus software, so Abaqus models are explained in details actually by the videos. And at the end, the result extraction from creep problems actually is explained in the videos. And all Abaqus and creep files are included in this package that you can download it. In this package, we have two examples. Example number 1, which is a simple creep in that most necessary details are explained for beginners. Example number 2, which is a medium creep, more details are explained. And in example number 3, which is a complex creep, all details are explained. You can simply download this package from the link in the description, or you can download this package by going to our website, which is feassist.uk. You need more. You don't have time actually to look at this package, and you want your creep to be written sooner, and we can write your creep, test it and verify that with published experimental results, and teach it to you in videos and actually online meetings. So you can download this package or order your project by the link in description or directly going to feassist.uk. Thank you for your attention. Hello. Here we want to explain composite or CFRP fatigue by VUMAT in Abaqus. You can learn it easily and quickly by this video. We have explained the fatigue without damage, as you can see, and fatigue with damage, as you can see in this video. To understand how to do that in details, stay with us. We say you can learn it easy and fast, but is it really possible to learn it in a week? How? VUMAT subroutine has many variables, But do you really need to understand all details to solve your problem? Of course not. Only necessary aspects are enough for you. By focusing on your problem, your formulation, and your variables, you can save your time and your energy. To this end, we have prepared a training package for you. Composite Fatigue by VUMAT in Abaqus. This package includes videos, a formulation about fatigue damage and composite damage and composite fatigue are explained in video. VUMAT variables are explained in another video. In the next video, the whole VUMAT subroutine is explained line by line for the beginners. Any VUMAT needs to be solved by Abaqus solver, so the Abaqus model is explained also step by step in another video. At the end, a video for result extraction. And all Abaqus and VUMAT files are included also in this package. This package includes 3 examples. Example number 1, which is a simple VUMAT and most necessary aspects are explained. Example number 2, which is CFRP damage VUMAT, because for fatigue maybe we need damage. So more details are explained in example number 2. Example number 3, in which the fatigue CFRP VUMAT is explained. So all details are included in this example. You can download this package by the link in the description or directly go to the faaassist.uk. You want more? You don't have time and you want your VUMAT to be written sooner? Okay, we can write your VUMAT, we can solve your CFRP fatigue problem, test it, verify it with published results, and teach it to you by the videos and online meetings. Again, you can order your project by the link in the description or directly go to the faaassist.uk. Thank you for your attention. Hello? Here we want to explain composite or CFRP damage or cutting by VUMAT subroutine in Abaqus. You can learn it easily and quickly by this video. The first solution is micro. In micro solution, the fibers and matrix are defined separately. You can see the cutting process here. The fibers are oriented in 0 degree in this example. Or here you can see the strain in the elements and the chip formation. The second solution is macro. You can see the chip formation and cutting process here. To understand the details of how to do that, stay with us. We say you can learn it simply in a week, but how? The VUMAT to solve this issue has many variables, many inputs, many outputs. But do you really need to understand all details to solve your problem? Of course not. Only necessary aspects are enough. By focusing on your formulation and your model, you can save your energy and your time. To this end, we have prepared a package for you, which is Composite 3D Damage with VUMAT. In this package, the formulation is explained in the video. The VUMAT variables are explained in the video, and the whole VUMAT of cutting process of composites are explained line by line in another video. The Abaqus model is also explained step by step in the next video. And at the end, the result extraction from the cutting process is explained. All Abaqus and VUMAT files are also included in this package. This package includes 3 examples. Example number 1, which is a simple VUMAT and most necessary aspects are explained. Example number 2, which is a macro CFRP cutting VUMAT and more details are explained. And example number 3, which is a micro CFRP cutting VUMAT and in which all details are explained. You can simply download this package from the link in the description or directly go to feassist.uk. You want more? You don't have enough time? You want your VUMAT to be written sooner and your problem to be solved sooner? Okay, we can write your VUMAT and solve your problem, test it with published results and teach it to you in videos and online meetings. Again, you can order your project by the link in the description or directly go to feassist.uk. Thank you for your attention.